This is Chapter 12, Basic Editing by Mary Beth Price, Mastering ArcGIS 5th Edition. Some basic editing tasks that you'll be performing will be digitizing new features from a paper map or scanned map, construct new features from survey descriptions, we won't be doing that one, map areas or objects based on air photos or satellite imagery. You'll be using some layers that have satellite imagery. Update features that have changed since they were created, or fix errors. You'll be doing that if you make any errors. And update or correct attributes of features. You'll be doing that as well. Logical consistency measures how well features in the dataset mimic the relationship of the features in the real world. Basic editing is concerned with two aspects of logical consistency. Make sure that ends and corners meet at a common vertex so we don't have any half buildings for our example, and making sure that adjacent polygons share an identical boundary. And that would be if you were creating a multiple building layer, but we won't be doing that. How do we maintain logical consistency? We avoid dangles. In this case, a dangle is shown because two lines fail to connect. The correct topology is the bottom one, where the horizontal line intersects the vertical one, creating three different lines. One here, and one here. Here there are just two lines. Snapping tolerance. We use snapping to make sure that we snap or get all of our lines together. Snapping tolerance is the minimum distance between two vertices at which they are considered to be identical. And the way we do that is we set a snapping tolerance, and once you get to within a certain distance, your mouse or the end of the line in this case would actually connect. B would connect to A. In this case, it doesn't connect because it's not within that tolerance, so that C would not connect to A and B connecting there. And notice that this snapping tolerance is kind of off because it's not equidistant around the point. If technically if B were over here and not in the snapping distance, it wouldn't connect, but in reality it would, because the snapping distance would be around, it would be the distance between the 2 points, and if B was over here it would connect. Tolerance units. You can set it to screen units, in which the number of pixels on the screen, that helps it to remain consistent regardless of how much you are zoomed in, and it's easy to work with at all scales. Whereas map units, the user sets a tolerance in map units such as meters, feet, and degrees, and it ensures consistent precision at all scales. It may become difficult to work with when you're zoomed far in or far out from the normal editing scale. We will zoom in very closely, as you will see in the directions. I actually tell you what level to zoom into. Types of snapping. Here we have some point snapping, end snapping, edge snapping, and vertex snapping. It is important to learn what these icons mean if you intend to use snapping, for example, or editing in your project in later courses. In snapping for points, we can make sure that the sewer connections fall exactly on the house edge, or ensure that stream gauges fall exactly on the stream. Snapping for lines, make sure that road ends meet at other roads, and ensure that stream segments connect to each other so we don't have a stream that technically connects but looks like it doesn't. Make sure parcel corners match, and in this case the it's saying that it should have been snapped to an existing corner. This one looks like that case. It should have been snapped to an existing corner. I'm not exactly sure what they're looking at here, because this technically could be a corner. And it avoids creating spurs or nooks and kinks between polygons. In this case, we have adjacent polygons, and to maintain logical consistency, we would not create polygons that were like this. We would want to snap them to it so that they share a boundary. If in fact they do share a boundary. Here they do share a boundary. We can use a special tool to construct adjacent polygons. We can create a polygon and then cut it into two pieces. That's just two different ways to do it. Now some about ArcGIS and basic editing. What can you edit? Well, in ArcInfo, which we're using, or ArcGIS Desktop Advanced, you can edit geodatabase networks, geodatabase planner topology. Coverages can no longer be edited in ArcMap. You must convert them to shape files or geodatabase feature classes. I doubt you'll find any up-to-date coverages for use in any of your work. Tips: always have a backup copy. Open new map documents for editing and only add the layers you need. Keep the number of open files to a minimum. Keep the layers in the same coordinate system. We should axe the word try to, because we're going to be advanced GISers. We're not going to deal with incompatible coordinate systems. We're going to make it right. And save often. Sometimes editing corrupts map documents. It is recommended to your editing in documents specifically open for that purpose, containing the minimal number of files you need. Try not to edit in your gorgeous map layout documents that took days to develop. You may want to make sure that you have multiple saves while creating your Lab 5 deliverables. The editor toolbar. Lots of new icons to learn. We'll have a new toolbar. There'll be a menu, an edit tool. These are the sketching tools. This is how you edit vertices. This is how you reshape. Cutting a polygon, as we talked about a couple slides ago. Split a line. Rotate. The attributes, you'll use this a lot. The attributes, the sketch properties, and also create features. You will set snapping toolbar, and you'll set the options. I will tell you what to set. These are some of the items that we'll be using in Lab 5. Save early and save often. If you stop editing, it will ask if you want to save your edit, whereas save edits will just save and continue editing. I would use save edits often once you make sure that it's what you want. How editing works. You would create feature templates. These are the items where you could create any sort of polygon, a specific rectangle or square, a circle or an ellipse. You can draw by freehand or an autocomplete polygon. I'll give you the specific directions in the lab. We won't be using this portion, but you will add rectangles and also polygons. In this case, the person drew, and at the very last click, I believe that there should be a green square there, because they're making it solid. I think that's an error. You double-click the vertices of a sketch, or you double-click Finish the Sketch to finish. Edit tool. It's used to select features so that they can be moved, deleted, or edited. Uses the same techniques as the Select Features tool. Creating adjacent polygons. These are the steps. I would refer back to this slide often if you need to create adjacent polygons. We will not be doing so in this course, but it may come up in future projects. You can remember to come back to chapter 12 and maybe even watch this video again, although the directions on this slide in the book will be plenty for you to comprehend and do it on your own. The same with splitting polygons. We won't be doing that, so I'm going to skip over it now. Moving a feature, pretty self-explanatory once you read the directions. Skip, we won't be moving features. Deleting a feature, you highlight it, press delete. This is how we edit vertices. Hopefully yours will be good. You won't need to do any editing. Here we have some rotated features. We'll be drawing right on an ortho photo, so you don't need to worry about that. Splitting lines. I actually came back to this chapter several months ago when I was doing extensive editing, spending hours and hours and hours at the computer editing data for a Hood River Trails map. Editing context menus. You could right click on the sketch and right click off the sketch. You get a vertex menu over here or a sketch menu over here. You will need some of these as you're doing your editing. The vertex menu gives you several options, and this is more easily learned by doing rather than reading. And here the sketch menu talks about what you're actually getting, and again, it's easier to do and learn than just read. Here's some more options that you can have showing. We won't be using them specifically, but you should know that they're there. If you need to make certain length lines or you need certain X and Y positions, this could be done when you're creating your, in this case, a point feature class. Here's some more of the options. Multipart features we won't be creating in this course, but you could refer back to this as necessary. Editing sketch properties, you'll be doing that, and we'll also be using this icon, and give yourself a quick quiz. What is that icon for? If you don't know, back up a little bit or use your book to figure out what that icon is. You'll need to use it in Lab 5 extensively. Sketching tools. The straight segment is the default, and then there's some curves. There'll be the floating mini toolbar, which for new feature editors, that's annoying. You'll end up clicking it off a lot, but usually new users don't mind it. I'm used to editing so that that doesn't pop up, and it now is an annoying feature to get in my way. Here's a right angle sketch tool if you need a specific right angle. This is almost identical to what we'll be doing in our course. At the end we'll be finishing the sketch, but digitizing or creating features this way is exactly what we'll be doing. Arc segment, this is how you create curves. We won't necessarily need them this lab. The attribute, there's that window that I told you should know. Attributes, button, because you will be changing the attributes as you enter your data during the lab. There are specific directions in the lab videos based on the topic and also in the written directions. Here's some more editing of the attributes. Hopefully you'll get it right the first time. Creating new feature classes. Sometimes you need a blank empty feature class. We will be creating a blank empty feature class, and you create that with the Arc catalog or the catalog tab and or Arc toolbox before you can start editing it. In the tutorial in the book, you would create 3, but we're only creating 1. Here's the directions on how to create the one using a geodatabase. We'll be doing a little bit different method. New feature classes ready for editing. This again is in the book. We're not doing that involved of an editing session. And this is just a final slide talking about editing one folder or geodatabase at a time. We'll only be doing one, so we won't have to worry about that. And this concludes Chapter 12 of Mary Beth Price's chapter on basic editing.